to discuss the future role of nuclear in addressing the world's climate and energy needs. Joining me now is Seth Grae, the President and CEO of Lightbridge Corporation, a nuclear fuel technology development company. Seth, thank you for joining me. Looking ahead to the unprecedented growth and demand for clean energy of tomorrow and looking at the shortcomings of other alternative clean energy sources of today, is there a real solution that does not involve nuclear? What's the role that nuclear power can play, in your view, to reach net zero?
All of these studies show that the only way we will reach the climate goals by 2050 and energy security goals is to have significant growth of nuclear power within the diversified energy mix. Many countries around the world committed to tripling renewables by 2050, and also many countries committed to tripling nuclear power by 2050. Nuclear power will provide around-the-clock full energy for everyone who needs it, and combined with renewables, the total price of the energy for the system is less than with renewables only. So nuclear is essential for meeting net zero goals.
Society's attitude towards nuclear power ebbs and flows, doesn't it? In good, plentiful times, attitudes towards it are negative. And then in times of geopolitical crises and energy shocks, attitudes turn positive. Do you, Seth, think that given the climate change threat and the energy crisis of last year, the world is ready today to price in those risks and possibly pay a premium in order to insure against those risks by securing uninterrupted clean energy supplies that nuclear power can provide?
Well, I certainly think that the pressing needs to achieve climate goals and energy security goals help support nuclear power. I'm wary of saying people will pay a premium, will pay more for electricity. There are about 1 billion people in the world that live in poverty, including hundreds of millions of children. We have to deliver energy, including nuclear energy, that is affordable. That said, there will be some sectors in some countries that will pay a premium. For example, data centers owned by some of the largest companies in the world that are committed to decarbonizing their operations are looking at small modular reactors and advanced nuclear energy systems to power the data systems with zero carbon. But overall, nuclear needs to be able to compete and win against the market price of energy.
But how viable are emerging technologies like small modular reactors? What's exciting about this particular solution, and why should anyone place big bets on it?
The small modular reactors are very exciting developments. These SMRs, as they're known, can be used in remote areas or specifically for data centers or refineries or other systems to take them off the electric grid, keeping them resilient so that if someone attacks the electric grid, the facilities powered by the SMRs will still operate and do so with zero carbon power. And the SMRs can be produced, it seems, at a very large scale. Many of them produced, like Boeing produces 737 aircrafts. These SMR small reactors can be produced in a factory or in a shipyard and then shipped to the site where they're built instead of building everything at the site. And by producing many of them in a factory, that can do a lot to hold down the costs and make sure there's consistent quality across all the units that are produced.
Nuclear projects experienced significant delays and substantial cost overruns almost everywhere in the last 3 decades. Could SMR technologies change that?
We hope so. I think some of them will. They'll compete in the marketplace, and they're racing against each other now to have their first deployments and demonstrations and build facilities to mass produce them. But in nuclear, generally, the first unit of something that is built takes a little longer and costs more. And then as you get to the third, the fourth, the fifth unit, you seem to know the costs and the timeframes for deploying them from there. So with SMRs, where they can be built in very large numbers, potentially hundreds or more of the same type, I think those costs will be very well known and very predictable.
Seth, there's a lot of excitement around the utilization of SMRs to decarbonize energy-intensive industries, such as steel, aluminium, water desalination, among others. It could also produce clean hydrogen that could in turn decarbonize some of those same industries. Do you share that enthusiasm?
Yes, exactly. In addition to producing electricity, there are SMRs that can produce high temperature heat that can be used in industrial processes, including producing hydrogen. And that hydrogen can be used for many uses, including zero carbon liquid fuels for trucks, for many uses, perhaps for aviation fuel. So yes, SMRs for hydrogen looks quite promising.
How important are harmonized standards, clear regulations, and government support in order to help commercialize and scale up emerging innovations in nuclear energy, such as SMRs?
Harmonized regulations are very important. We're seeing progress along this area where, for example, the United States and Canada are working to harmonize some of their nuclear regulations, and other countries are as well. So if you license a nuclear technology in one country, you can have a similar process to have approval in another country. And what I'd like to do getting beyond that is something called country of origin licensing eventually, where there could be a respected nuclear regulatory authority in one country that approves a technology, and that's good enough for it to be used by a different country that simply reviews the approval and then approves it itself without going through the whole approval process all over again. We'll see this, for example, in aviation, getting back to 737s, where not every 737 that is produced has to be relicensed in every country it flies to.
There are numerous new SMR technology designs, Seth, currently being developed and seeking regulatory approval. How difficult must it be for regulators to handle such a large number of varied designs and assess their safety characteristics efficiently and in an acceptable time frame? How can the regulators and the industry address this challenge in order to streamline the approval process?
Right. In most countries, the regulators will prioritize which applications they will focus on or even accept. They will turn down some applications, and they will tend to prioritize those that have the most commercial interest, that seem the most likely to be deployed, and not have their resources diverted to systems that don't have as much commercial interest. And we're also seeing SMRs applying in different countries. So having one company apply in Canada, a different company apply in France, a different company apply in China, also keeps the regulators of those countries from being overwhelmed with too many applications.
In a future grid dominated by intermittent renewables, would SMRs have the ability to ramp power up and down? Could SMR accompanied by storage or SMR dedicated to hydrogen or desalination and then switch to the main grid be able to address this challenge?
Yeah, this is a very important issue, and the current reactors can't do that. With the current reactors, they cannot surge up in power very quickly and drop down in power very quickly to balance as the wind blows or the sun shines. But there are new reactor and fuel technologies that are being developed that will be able to do that. In particular, my company, Lightbridge, is developing advanced fuels that, among other benefits in SMRs, we believe will be able to go up and down in power, balancing with renewables on a zero carbon electric grid.
Finally, Seth, how different is the fuel that powers conventional light water third-generation reactors versus fuel that powers SMRs? And is there a new set of challenges that face the production of the required specialized fuel to power SMRs and other advanced reactors?
The current large reactors, like here in Abu Dhabi, or here in the UAE, the reactors in Abu Dhabi, have fuel rods that are made of metal tubes with uranium ceramic pellets stacked inside them. And some of the SMRs use that type of fuel with just shorter fuel length, and some use new systems that are very different, that don't use pellets inside tubes, that are not cooled by water, that could withstand much higher temperatures. And for the current reactors and for the SMRs that use the current type of fuel, what Lightbridge is doing is bringing a new advanced fuel that we believe will work in those reactors, bringing many advantages of advanced reactors to those kinds of systems.
Seth Grae, President and CEO of Lightbridge, thank you very much for joining me.
Thank you very much.